Welcome to the debate. You are listening to the WeCyberYou Unlocked podcast. And before we really get going, please make sure to follow the channel. And we ask that you visit WeCyberYou.com for more content like that.
Yes, definitely check that out.
So, to start us off, imagine handing a junior developer a corporate credit card, right? And giving them the ability to instantly purchase and plug in, say, 10,000 servers across the globe with zero oversight.
Sounds like a nightmare.
Right? I mean, 10 years ago, if someone did that, you would call it a catastrophic failure of corporate governance.
Oh, absolutely. But today? Today we call it agility.
Exactly. We call it agility, and we celebrate it as this massive operational victory, which honestly sets up our focus perfectly. Today we are looking at NIST SP 800-145, published by the National Institute of Standards and Technology.
The famous cloud definition.
Yep, the big one. Because before this document existed, the technology sector was building these massive, complex digital infrastructures without any agreed-upon language. Like, cloud computing was just this vague marketing buzzword.
Slapped onto legacy server hosting just to sell products.
Totally. And it created misaligned corporate strategies, incredibly poor security assumptions, and just total confusion around who was actually responsible for protecting the data. So NIST stepped in to cure that chaos by establishing the authoritative, globally used definition of the cloud.
But they did so by making the document purely definitional.
Right. It intentionally does not tell you how to secure the cloud. It only defines what the cloud actually is.
And see, that separation, that hard line between definition and security is exactly the core of the problem here.
Well, let's frame the central question we're debating then. Does NIST 800-145's purely definitional nature provide the exact clarity an industry needs to assign security responsibilities, or by defining the cloud without inherent security directives, does it abstract away the exact complexities that ultimately lead to catastrophic data breaches?
A very big question.
It is. And I take the position that this framework's strict adherence to being purely definitional is actually its greatest strength. By universally defining the essential characteristics and the service models without, entangling them in specific security controls, it perfectly establishes the structural baseline.
I just don't see it that way.
Well, it serves as the required foundation for actual risk management frameworks like NIST 800-53. I mean, you cannot govern what you cannot first clearly define.
Sure, but I come at it from a completely different way. Treating 800-145 as this definitive starting point creates a dangerous false dichotomy.
How so?
Because by defining the cloud purely through operational mechanics, prioritizing concepts like instant scalability and unhindered access while remaining entirely devoid of security frameworks, it normalizes the very conditions that introduce severe risk.
Normalizes risk?
Yes. The danger of NIST 800-145 isn't that it's fundamentally wrong about what the cloud is. It's that it teaches executives that the cloud is this simple utility like electricity, when operationally it is an active ecosystem that requires massive, constant governance.
Wait, I have to stop you right there. You're making it sound like those operational mechanics, rapid elasticity, for instance, are inherent flaws rather than features.
Not flaws, but...
Let's look at how the standard actually outlines the 5 essential characteristics. For a service to truly be a cloud, it must have on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service.
Right, the core 5.
Yeah. And if I am running a global e-commerce site on Black Friday, rapid elasticity means my system automatically scales up its resources to handle the massive influx of traffic. And measured service means I only pay for the exact computing power I consume during that spike.
Nobody's arguing the business value of that.
But isolating these definitions is what allows businesses to understand the economic value of the architecture. Think of it as an architectural blueprint. The blueprint defines what constitutes a wall, a load-bearing pillar, or a door. You do not put the wiring specifications for the security alarm system into the foundational definition of the door itself.
Okay, but if we are going to use the blueprint analogy, we really need to be honest about how this specific door functions.
I think the blueprint is pretty clear.
Is it? because in your blueprint, the door isn't just a piece of wood on hinges. When we look at the first characteristic you mentioned, on-demand self-service, NIST defines this as the user's ability to provision computing capabilities automatically without requiring human interaction with the service provider.
Right. Speed and automation.
Exactly. But you are defining a door that automatically builds itself and opens thousands of times a second for anyone who asks.
Which is the fundamental engine of modern digital transformation. I mean, if developers cannot spin up resources instantly, we are back to the legacy IT model, submitting a ticket and waiting 3 weeks for a physical server rack to be installed in a basement somewhere.
I am not arguing that we should return to submitting IT tickets. Come on. I am arguing about the mechanism of how this standard dictates behavior.
Behavior? It's just a definition.
But by establishing instant intervention-free provisioning as a mandatory requirement of the cloud without embedding security guardrails into that definition, you are directly mechanizing the top risks highlighted in the source material.
Mechanizing the risks. That's a stretch.
Think about how this actually functions in the real world. A developer makes an API call to spin up a storage bucket. Because NIST prioritizes on-demand self-service, that API call completely bypasses traditional network security review boards.
Well, yes, that's the self-service part.
Right. The API call provisions the storage, and the default setting on the provider's side might just be public. The standard explicitly warns us about identity and access mismanagement and misconfigured public buckets. Yet it creates a definition that essentially mandates the bypass of human oversight. The definition itself breeds the vulnerability by normalizing a culture of speed over safety.
But, that culture of speed doesn't happen in a vacuum, and it doesn't happen on dedicated hardware either. A developer can only spin up a server in 3 seconds because they aren't waiting for a dedicated machine to be built. They're just taking a slice of a massive, already running pie, which, frankly, moves us perfectly to the third essential characteristic, resource pooling.
Ah, yes. Multi-tenancy. The idea that the provider serves multiple customers using dynamically allocated shared infrastructure.
Exactly. And the source material is remarkably transparent here. It explicitly states, and I'm quoting, "You don't know exactly where your data is stored, and that matters for security." The standard is not hiding the ball. It is telling you upfront that the physical location of your proprietary data is abstracted away.
Acknowledging a massive existential risk while offering zero structural mechanism to handle it is an intellectual cop-out.
A cop-out?
Yes. The standard points out that your highly sensitive corporate data is sitting on the exact same physical hardware as potentially malicious actors or careless neighbors, and then it essentially just says, figure it out.
They aren't saying figure it out, they're defining the boundary.
If NIST defines the cloud as a utility grid, they forgot that in the digital world, a single flipped breaker in a shared substation doesn't just turn off your lights, it gives your neighbor the keys to your house.
That's a bit dramatic.
It's the reality. We're not just talking about separate virtual servers, we're talking about logical separation on shared hypervisors. When vulnerabilities exist at the hypervisor layer, you're susceptible to side-channel attacks, where an attacker monitors the shared CPU cache to extract cryptographic keys from another tenant. Defining resource pooling as an essential requirement without structurally tying it to isolation protocols is incredibly reckless.
See, I view that exact dynamic as the absolute opposite of a cop-out. Explicitly defining the abstraction of data location is exactly what forces organizations to finally kill that legacy castle and moat security mentality.
The perimeter model.
Security relied on a perimeter defense model. You put a massive firewall around your physical data center, and you assumed everything inside that perimeter was inherently trusted.
A model that failed spectacularly once remote work became the norm, sure.
Which is exactly why this definition is vital. By formally stating that the cloud operates on resource pooling, that you do not have a physical perimeter, and that your data is dynamically shifting across shared multi-tenant infrastructure, NIST 800-145 forces the customer to abandon the perimeter.
But does it?
Yes, it forces security engineers to realize that physical hardware boundaries no longer protect them. This mechanical realization is what actually drives the adoption of zero-trust architectures. It forces you to implement encryption at rest, encryption in transit, and incredibly strict identity-based access controls. The definition highlights the abstraction specifically so that engineers know they must secure the data itself, not the facility housing the data.
Okay, I hear your argument that it forces an evolution in security philosophy. But look at the cognitive load this places on the average organization. We're talking about a standard that applies globally across every sector, from massive tech conglomerates to regional hospitals.
Right. It's universal.
But not every company has an army of cloud-native security engineers ready to implement zero-trust architecture. When NIST defines resource pooling simply as a mechanical function, they are relying on the customer to intuitively understand that they need to overhaul their entire corporate security philosophy.
They have to survive the environment.
Right, just to survive the baseline definition of the product they bought.
But they aren't relying on intuition, though. That is why NIST 800-145 goes beyond just listing characteristics and explicitly outlines the service models.
The acronyms.
Yes, we all know the acronyms: IaaS, PaaS, and SaaS. Infrastructure, platform, and software as a service. The standard doesn't just throw you into a pooled environment, it defines the progression of operational control.
Theoretically, yes.
In IaaS, the provider controls the underlying hardware, but the customer controls the operating system, applications, and data. In PaaS, the provider takes on the OS and runtime, leaving the customer to manage only the applications and data. In SaaS, the provider controls almost everything.
Which sounds very neat and tidy.
This clear demarcation of control empowers leadership. A chief information security officer uses these exact definitions to secure a budget. They can walk into a boardroom, point to the definition of IaaS, and say the provider is only securing the physical servers. The operating system and the data are entirely our responsibility. It allows them to draw a hard line in the sand.
Okay, if you are a cloud architect listening to this right now, you are probably screaming at your dashboard.
Why? It's the shared responsibility model.
Because you know that in the real world, shared responsibility usually just translates to shared blame during a post-breach audit. I reject the idea that these neat conceptual categories empower anyone because they fail completely in the messy reality of enterprise architecture.
How do they fail? They clearly assign who does what.
Let's look at a specific fact from the text. Most cloud breaches happen due to customer misconfiguration, not provider failure.
Which proves my point perfectly. The provider is successfully securing their portion of the model. The breaches happen when customers fail to secure their designated side. The definition holds up.
No, the customers are failing because the service models oversimplify a highly complex operational reality, especially when you bring in the deployment models from the text.
You mean public, private, hybrid, and community clouds?
Exactly. Let's dissect a realistic scenario involving a hybrid cloud. A large enterprise uses their on-premises Active Directory to manage employee identities, right? But they federate that identity management out to a public cloud provider's IAM, Identity and Access Management, to control access to a PaaS database.
A very common setup.
Very common. And NIST 800-145 says the lines are clean. You control the data, the provider controls the platform. But the failure happens in the transit layer, in the API calls between the on-prem directory and the cloud IAM.
That's a configuration issue, though.
But the logging between the on-prem environment and the public cloud is completely disjointed. A compromised on-prem credential can generate a valid token that extracts data from the PaaS database, and neither the on-prem firewall nor the cloud provider security tools flag it as an anomaly.
Okay, but you are describing an execution failure in identity federation, which is incredibly complex. Complexity in execution doesn't invalidate the underlying definition of the environment.
The complexity thrives in the gaps created by the definition. Because 800-145 explicitly distances itself from security governance, it creates a dangerous illusion of control. The executive leadership thinks, oh, we understand the service model, we know what PaaS is, therefore we understand our risk environment.
They should still be doing risk assessments.
But that lack of cross-environment visibility is exactly where misconfigurations inevitably thrive. The theoretical model tells you the lines of responsibility are clean, while the technical reality proves the lines are a highly porous mesh.
I really have to push back on the idea the definition creates an illusion of control. If NIST 800-145 tried to mandate the exact IAM federation logging protocols for every possible hybrid configuration, it wouldn't be a definitional standard anymore.
It would be a security standard.
It would be an encyclopedia of every possible technological permutation, and it would be outdated 3 days after it was published. Let me bring us back to the intended relationship between this document and the broader cybersecurity ecosystem.
Go ahead.
The text clearly positions NIST 800-145 as the absolute foundation layer. You have to establish what you are looking at before you can measure the risk. Applying the rigorous risk management lifecycle in a framework like NIST 837 becomes completely inconsistent if you don't even have a shared vocabulary to determine whether you are evaluating a PAS database or an IAS virtual machine.
I hear that, but a foundation poured without rebar is going to crack under the weight of the building. We are living in a world completely dominated by cloud-native applications and global digital supply chains. The cloud is the absolute backbone of modern business.
Agreed.
So we are far beyond the point where we can afford to define the foundation of global commerce without simultaneously mandating how to protect it. When a CEO reads the simplified definition that the cloud is just on-demand access to shared computing resources scalable and billed based on usage, they see a frictionless financial and operational tool.
That's the business value.
But they do not see the mechanical reality of side-channel attacks on shared hypervisors or API vulnerabilities in hybrid deployments.
No, that CEO is not the one configuring the hypervisor. And the standard isn't meant to be a replacement for specialized engineering knowledge. It is meant to provide a universal language.
I just think it misses the mark by stopping there.
I maintain that NIST SP 800-145 remains the backbone of the industry specifically because it is framework agnostic. It successfully took a chaotic vendor-driven landscape and instituted a rigorous, globally distributed common language. By strictly separating the operational mechanics, the characteristics, the service models, and the deployment models from the granular security protocols, it serves as the necessary first step.
And I maintain that separating the definition from the danger is a luxury the industry cannot afford. Defining the cloud as a set of high-speed, multi-tenant utilities without structurally integrating governance sets a very dangerous precedent.
It's a foundational step, not the whole staircase.
But a purely definitional baseline, one that highlights massive systemic risks like abstracted data location, but offers no integrated solutions. It leaves organizations to navigate the brutal complexities of shared responsibility completely on their own.
Well, it is a profound tension in how we approach technology governance. And I will certainly acknowledge your point regarding the hybrid cloud scenario. The clean conceptual lines of IaaS and PaaS can absolutely mask the severe operational dangers of disjointed logging and identity federation.
And in fairness, I will concede that without this exact vocabulary, applying robust, certifiable frameworks like ISO 27001 across different vendors would be entirely impossible. We just fundamentally disagree on whether a structural framework of this magnitude can divorce operational definitions from cybersecurity execution without causing immense collateral damage.
Absolutely. And, for the practitioners listening who are navigating these architectures daily, we highly encourage you to pull up the original NIST SP 800-145 documentation. Look closely at how the characteristics and models are defined, and draw your own conclusions about where the definition of the operational structure ends and the security of that structure must begin.
Ask yourself if you feel comfortable building your enterprise based on a blueprint that defines the utility grid but completely ignores the locks on the substation.
A perfect thought to leave our listeners with today. You have been listening to the WeCyberYou Unlocked podcast. Please make sure to follow the channel and visit WeCyberYou.com for more content like that. Keep questioning the foundation.